Okay, for number three, it looks tough because I'll be honest with you. It says, let G be the inverse of F, and F is a cubic polynomial. And if I were to simply say, I'll just try to find the inverse, and I'd write y equals, what does it equal? Y equals x cubed plus 3x plus 6. And then I would say, x equals y cubed plus 3y plus 6. And if I have to solve this for y, it looks like it might be a challenge for me. All right? Now, you could show it's invertible, but right now I'm going to assume it's invertible because I said, inverse of. So I'm going to assume it's invertible. Now, again, you can graph it out if you like, and you can probably note by graphing it out that it's an invertible function. But what I want to do is get to their question. Right now, f of x is equal to something. And what they want is, g of x. I don't know what that is at this point. But they want to know what g of 20 is. And I'll tell you, I don't know. So what I want to write down is what that looks like to me. There's a 20 here, and there's a question mark over here. Now, this is g. I'm going to write down what f would look like. What would f look like? The question mark would be here, and the 20 would be there. I think this might be doable. And let's write that down. 20 equals x cubed plus 3x plus 6. Now, someone says, what do you mean doable? From what you learned in Math 120, it's a cubic, right? So what do you get? You get 0, x cubed plus 3x minus 14. So I'm kind of looking at that, and I'm wondering what number would do that for me. And I've used what's called the rational root theorem. Rational root theorem. It's what you learned in Math 119. So I'd be looking at factors of 14 that might do it, like 1, 2, 7, 14. I couldn't go beyond that, though. 1's certainly not going to work. -1's not going to work. But it looks like 2 might work. So, for example, if I took x to be 2, would it satisfy that equation? Let's put it down. What's 2 cubed is 8. What's 3 times 2 is 6. Minus 14. 2 works. All right, let me get my eraser out and say I found it. And I'll put it down. Then we'll check the key. Let me get my eraser out again. And again, by using what I knew about inverses and the rational theorem, I'm saying g of 20 is 2. I'll put this over here. I got that right there. I got that one right. And let me just erase my work over here. I'm kind of done with this business. Got a bigger eraser out. And I want to go to the next question. And before I do it, I want to talk about what they're asking for. They're asking for g prime at 20. All right? So I'm looking at this over here, and this is f, and this is g. I'm going to look at f first, by the way. I'm going to write f prime down. And what's f prime going to be? 3x squared plus 3. And what's f prime at 2? Let's think about that. That's going to be 3 times 4 is 12, and 12 plus 3 is 15. I'm sorry, I put 16, but I said 15. That's weird. Now, again, I want to point out, whatever this function looks like at the point, put this over here. I'm not saying that's what the function looks like, but it's sort of. This is the point 220. Do you want to know, I know there's a tangent line over here. And that guy's tangent line is a slope of 15. Now, I hope you realize when I take the inverse, I'm rotating, right? So then the slope of g, well, I'd be looking at the point on g now, not 220, but 22. And the slope of that tangent line would be rotated too, about the line y equals x. So that means the slope over here, at this point here, would be 1 over 15. All right, so I'm going to make that claim now. So g prime of 20, I think that's what their question is. I'll go back and read it to you. I'm going to say is 1 over 15. Let's look at the key. There we got it. You got this over here, calculate it. Yep, 1 over 15. Again, my pictures it just helps me work through the problem. I'm not saying they're terribly accurate. All right, thank you.